Okay, then I keep it completely in English.
Okay.
Okay.
Thank you.
Yeah, that's good. Thanks very much for the invitation. I just wish that I was in Pakistan, then I can join in person. It's always good to go and visit back COMSATS. And if I ever go Pakistan, and if you bribe me by offering the chawal chole from Hanif's shop, I can drop by, no problem. Right. So keep in mind, if I'm in Pakistan and if you want to invite me, there is a bribe. Okay. The topic, when I received the invitation from Sohail Saab, I thought that, okay, what I can tell more, and which you don't know already. And one thing which came immediately to my mind is about my journey from mathematics to computer science, and then I can pretend to be a little bit of data scientist. So, to begin with this journey, let's start. Just like most of you, I was a bachelor student back in 2002 in COMSATS. It was CIET at that time. It was an institute, and we were part of the pioneer batch. And I think so. Sohail Saab joined when we were already in fourth semester or something, if I remember correctly. There are two things I like to mention here. One thing is when I was there studying, the perception I got about mathematics was that if you want to prove something, it is a pure mathematics. If you want to include computers somewhere in the system, it is computational mathematics. And if you want to take derivatives and do tedious calculation, then it is applied mathematics. That is kind of a thing which was happening around, right? And I was interested in more in the computational side. And this is a nice anecdote without hurting anyone. One thing was sure, at least to me about myself, is that there is one topic I will never do a PhD or master in, and that was fluid mechanics, because there were too many people doing that. Actually, some of them are actually your teachers. So that was pretty sure. Then after that, there was a higher education commission scholarship. So I was applying for scholarship. And here comes the second interesting thing. I don't know if Sohail Saab remembers that or not. But when I was filling out the form, I saw the name of a country, the Netherlands. I had no clue where it is, right? And I was in the campus, so I was walking somewhere. I saw Sohail Saab. I asked him, "Sir, do you know about where is Netherlands?" And his answer was, "Do you know Holland and its hockey team?" I was like, "Yes, I know." And his answer was like, "Yeah, it's the same country." So I still remember that, and I tell to many my colleague this anecdote that I ended up in a country, and now I'm spending my life in a country where I don't know the name even. So that's how I started. So the first thing, but when I started my master here in applied mathematics, coming with the background of pure and numerical and applied, and then it is really a clear distinction in Pakistan to a certain extent. I came and I thought, okay, yeah, it is MSc applied mathematics, so I will do applied work. So I will do some tedious calculation, probably write once in a while some program, and I'm done with it. But in the first lecture, I was they expect me to start proving theorem. So what is applied in their mind is that analysis is pure because someone has created those framework to be able to prove some theories. And now we should be able to apply that framework or those fundamental theorems or theories to prove another interesting things, which could be about an application. And my application was mathematical optimization. To me, it was a complete new definition of applied. I actively avoided to learn how to prove theorems. In most cases, I think so half of you are also doing it. is we just memorize the theorem without thinking that, okay, they are not topology, analysis, algebra. They are, so we just memorized it. So I was good in numerical math. I was good in this differential equations and discrete math and all those things, but pure analysis, algebra, topology, I was not really good in. So I just memorized it and lived. And I did good in when I was in COMSATS. That's why I got the job immediately. So that was my start for. Sorry, some.
आवाज नहीं आ रही हमें आपकी।
Yes, my Microsoft is muted every 1 second automatically. Can you hear me now?
Yes.
Okay, good. So that was my journey. And then I start doing my PhD with an idea that I will do a lot of numerical computing there. I chose a topic on, and then in the first year, it was pretty much apparent to us that we have no theory to make numerical about. So we have to first develop theory in the topic. And then I ended up writing a PhD thesis where I cited or proved these many theorems just to a little bit show off here and finish my PhD and be done with it. I will come back to my topic of PhD. That is my journey about mathematics. Then after mathematics, there is a joke. What is the difference between computer scientist and mathematician? And the answer is one can afford pizza, other cannot. And you know which one can afford pizza. So I finished my PhD in mathematics, and then I look in the job market. It was not really ripe at that time. I'm talking about 2014. So I started another degree, engineering doctorate, which is special, which happened in Netherlands. So I started engineering doctorate. And there I learned about it. It was together with the Philips research. So my whole work was with Philips research for 1.5 years. And there I learned about machine learning. And one of the fundamental problem I worked with that there was about sleep stage classification. For the first time in my life, I come to know that even in our sleep, we have different stages. One is REM. REM is when you move your eyes too fast, or if you have a sleep where you feel like you are not sleeping, that's REM sleep. And then there is a deep sleep, and there are three more stages. And then you can detect it using heart rate variability. I have no clue what is heart rate variability before that. And then I started reading about it. So it is basically an ECG where you see two peaks, you take the time between these two peaks, you note this time, and that's heart rate variability. And then you can do a lot of it. Sometimes I teach machine learning or time series, and I ask a question, do you know what is my favorite time series? And I answer it myself always, and I say it is basically RR interval, because this is just one column of data, and from this one column of data, you can compute so many things. How many of you have a watch which has a green light below it? If you have that watch, it means there is an RR interval being computed, and all your data about stress, your walking, and everything is computed using that number, right? So this green light is a PPG technology, and that is the basis from where everything starts. So it is an amazing time series, or if you're talking to electrical engineer, an amazing signal. So this is how the journey started. And PhD. Okay, first I have to give a lecture on in Urdu Bhashan. It looks better, Bhashan. So what is mathematics? I think so all of you know the definition of mathematics, but I use a slightly different definition of mathematics. So what is mathematics? It's not a science, it's an art. I think so. I have seen this discussion happening so many times. probably I'm mistaken, and it was again Sohail Saab who used to call it as art also. I'm not sure. Don't quote me on that. He's sitting, that's why I can say it like that. Mathematics is art of discovering the real facts about imaginary object. And when we talk about imaginary, how many of you have seen spaces or groups or abelian groups and tangents and all those things, right? Of course, in geometrically you can draw them, but they are still imaginary. We fight so much proving things about it then, right? Because they are useful. So we are our what is our toolbox? We have abstract notions, we have axioms, and this is a fundamental issue with the mathematics that we like to prove everything, but there is a limit. And because there is a limit, so we have to do something about it. And then instead of going in the circular that, okay, you want to prove it and go in circle and circle. So what we did is we defined some set of rules, which we say that it's true by definition. These are axioms. And from there, you can build a whole. So there are no universally accepted, universal axiom for whole branch of mathematics. But for example, in set theory or logic, you can find some, and in abstract algebra, you can find some axiom on which, especially there are more famous axiom in geometry. So you can build it. And then on basis of these fundamental principles, you can do the logical deduction to formulate your proof, and which leads to perfectly correct statements. In mathematics, what is true today is true forever. It's not a computer program which is running now, and after 5 minutes there is a bug and you are done with it. And also, whatever is old is a gold in mathematics. Yeah. If you prove a 20-year-old conjecture, probably you get a master. But if you prove a 100-year-old conjecture, probably you win a big prize also together with your master or PhD. So that's the definition of mathematics, probably not the one which is famous one. And then from there, you can extract another definition, which is computational mathematics is the art of producing imaginary fact, all this number crunching about imaginary objects. Again, you are talking about grids, right? And you're talking about simulations and all those things, and they are all imaginary. We have just created them. I don't know if they exist or not exist. So we have a lot of iterative procedure implementation. I'm pretty sure if you have seen numerical analysis, you have seen some of those algorithms. Even just connecting that to me, the first day when I felt good that I can program was the day when I implemented Gaussian elimination method myself. The whole idea that I need 3 loops instead of 2 to implement everything was a revelation for me. And that's the day I was very, very happy that I can do those things. But that was very old time. Then coming slowly from computational mathematics to mathematical optimization, this is where I studied my mathematics part. I don't know if it is part of your curriculum or not, but when I was Pakistan, it was one of the standard thing. In our time, it was not there, but after that, I heard that it was introduced. So the idea is to minimize something with respect to something, which we do everything actually, everyday life. So we have constraint optimization if you put some constraint, unconstraint if you don't put any constraint. So this is a very broad mathematical formulation of mathematical optimization. So what exactly was my PhD about? My PhD was about optimization can be broadly divided into convex and non-convex. Convex means that if you take 2 points, if you can draw a line without going out of that shape, that's convex. And
Faizan, we can't see your slides. If you're
you can't
sharing your
see.
slide.
Sorry. Um, can you see now?
Yes, we can see now.
Okay, something happened. I don't know what. Have you seen any of the slides?
This is the first slide we can see.
Oops. I thought I'm talking about talking using the slides. Sorry. Okay, let's continue from here. Okay, that's interesting. So we have mathematical optimization, and then we have convex and non-convex optimization. Convex being considered as one of the easy set of optimization because there you can have only one optimization. Yeah. Consider of a parabola. Parabola has always one minimizer, so it is a convex set. One example of convex. So my PhD was to convert non-convex optimization into convex optimization. That was the idea of a PhD thesis. And the older work or the earlier work was mostly focused on semi-definite optimization, which is a special kind of optimization, which has the same purpose. You want to convert non-convex problem to a convex problem. And the difference was that we want to convert it without losing or without compromising on the approximation. We want to make it exact reformulation. It was not, I started it. The work was already there for already I started PhD in 2010, and the pioneer paper on which I started was published it was first print was in 2006, and it was finally published in 2008 and 9. And then there were one PhD thesis before me, which was touching these topics. And then we are in the same time, bunch of 10 or 20 PhD students from different universities in Netherlands and Germany were working on the similar topic on a different direction, but on this topic of converting non-convex into convex. So what we did, what I focused on sensitivity of solution, that if I change a little bit, what will be impact, stability, optimality condition. Also think about if we cannot find the exact solution, can we define a series of solution which can approximate things like those were there. But it was all mostly theoretical. So that was more or less my PhD. Then I call it my last serious attempt in mathematics. One of the last paper I wrote, which is really about mathematics or touching a lot about, is on maximization of homogeneous polynomial over the simplex. It was in 2021. And when I say I'm happy, I don't know if Faisal joined this session or not. He's also one of the uh, pioneer student of COMSATS. And then he did PhD with me when I was still in Institute of Space Technology. He defended in 2022, and his thesis title was Cone of Tensor with Application to Polynomial Optimization. We still have a list of open problems, which we discussed over the year. And because I'm not pursuing it, so if you want to, you can probably contact him. Yep. Probably most of you know him already. So if you want to ask about more broader open challenges, even there is Pardalus is one of the person who wrote too much about mathematical optimization, books, volumes, everything. And even when I was preparing this slide, I was looking, oh, what are the open problems there? And then I find out that he even wrote a book about open problems in optimization and data analysis in 2018. So it's filled with a lot of open problems which could be solved. And the other work which I remembered from my PhD time was work of gene peptides. And it was some open question, but they are really at a higher level. So it's each open problem in Hidayat Uruti's paper is actually a full PhD, fundamentally. If you want to try something more accessible and which can work more analytically with the matrices, the work of Miriam Dur, she was my evaluator of this PhD thesis also, and we wrote one paper at least together. Her open problems in the theory of completely positive and co-positive matrices, it is a very good place to start working on some problem. So that was my mathematics career. And then if I thought about, okay, because I promised that I will tell you something about some open problem in mathematical optimization. So still hypergraphs and their eigenvalues are not computable still easily. There is a work of Shi. He worked in University of Hong Kong. He has a list of papers coming on this topic, but still the problem is not solved, especially the numerical algorithm do not exist. Yeah. For all the graph questions, they do not have a similar equivalent in the hypergraph space. And one thing which I was interested in is the eigenvalues and eigenvector because it can be formulated as a polynomial optimization problem. And there I am. So that is one thing. Representation of tensors, multidimensional array matrices are nice, but what to do with the higher dimension? This is more relevant with the machine learning and data science also. Uh, it is very, very particular. The next part, polynomial time algorithm for pentadiagonal co-positive matrices. I have this problem since I was a second year PhD student. So, which means it's almost 13 years ago. I am pretty sure there is a polynomial algorithm, but I cannot figure it out yet. And I'm not searching actively anymore also. And the last part is stability and polynomial optimization over simplex. So that was my journey as a mathematician. Then comes the journey of a data scientist. What is a data science? It's a field which uses statistical techniques, methods, processes, systems to extract knowledge from the data. Data can be structured or unstructured. What is artificial intelligence? We do pattern recognition, right? And planning for action. It is funny when you talk about artificial intelligence with anyone, people immediately jump to the conclusion, oh, you are talking about machine learning. No, if this is my view of machine learning, that artificial intelligence is around from the time of from 1955, and the definition was there. People were working on it there, and it has different phases. And during those phases, different things came. And what is the technology to enable pattern recognition these days? It is called machine learning. This is the technology current. But before it was rules, it was logic. Uh, I taught a course in a language which is called the prologue, right? It is about logical detection. Okay, the idea is pretty simple. He is a daughter of that and son of that. What is the relation of these two, sister and brother? If parents are same, they are sister and brother. So you can deduct this knowledge. So there is even a programming language which was somewhere from 80s. I taught a course two or three times on that. So that was the technology at that time, actually, Prolog, to do this AI. So if you look at the history, there is a winter from 75 to 90, there was nothing happening, and all of a sudden it started moving. And another misconception that all of a sudden something happened. What happened is that these neural network theories start coming in the 60s, and then in the 80s it was fully mature and developed, that it is all the nice theorems which can be proved about it were already there, the fundamentals were there. What happened in 2010 to 2020 is it became computationally feasible, and that is a fundamental difference we need to realize. Before that, it was there. Even we have a professor in our department. He did his PhD in 1992, and topic of his thesis was neural network for pattern recognition. That was the title, right? So he wrote thesis 1992, but that was computationally very limited. But now computationally it has become feasible. Technology is there to crunch big numbers. Before it was not there. And after 2022, it is even going at a higher pace. Although GPT-5 is worse than GPT-4. If you are looking for something, don't use GPT-5. It's the worst thing you will do, my opinion. So what is the types of machine learning? Unsupervised, supervised, semi-supervised learning, and reinforcement learning. Reinforcement learning is the technology, basically, together with transformers behind GPT or the large language model. By the way, I heard because I am on the COMSATS pages, different channel. There was a data science track also within the bachelor program. Is it happening or not happening? I don't know.
It
Otherwise,
started,
I'm
and I think uh, many students here are from that program. As you can
okay.
see,
So
BMD. So all these students are from that program.
okay, okay, great. So probably for them this is a repetition. Then this is traditional. This is a categorization of machine learning, and then we go into deep learning. And the joke about deep learning is it's all about cats and dogs. All the examples are about these two animals, networks, activation functions, and layers upon layers of mathematics, right? So I will come back to it, that what will happen there and which kind of mathematics basically you need. And like I said, that okay, the revolution started coming from 2010 or so, but LeNet was already there in 1998. And the fundamental problem they were solving is the handwriting recognition, because it was a very expensive problem. Imagine the scale of postal service where the addresses are written by hand and they have to be sorted out, and there are millions of letters which has to be delivered every day. So if you can do automate it, you can save a lot of money. And that is why many people are spending a lot of money to solve it automatically. And that is the reason still one of the fundamental data set, MINST data set, is about letter recognition, because it is one of the oldest problem. We need to crack it. Although the accuracy of these models were achieved already in late 90s, around 97% or so, which is pretty good actually. But still it is used as one of the fundamental. YOLO is one of the most advanced one for computer vision task. And I think so YOLO 2025 is even work with the to multi-modal modality, also text and images and all those things combined together. But I have not checked it myself for a long time. So there are like major structures. So what we do as a data scientist, we ask, we collect data, we process it, analyze it, and insights. We draw insights. I supervise roughly uh, 20 to 30 students every year, from bachelor, master, and I have three PhD students also with me. And usually they are very good in the number crunching parts. They can use machine learning algorithm very well. So if you want one tip which will differentiate you from others, it is about insights. It's not about analysis. It's not about anything else. It's about insight. And if your process is correct. Last week, a student showed me their results, and the accuracy was 56% for a binary, which is close to randomization basically. And I did not complain about the accuracy. What I was asking about is about the process. If the process is correct, this is what you can do with the data available to you. Not every data you can achieve 100% accuracy. That's how at least I evaluate it. So that's the process, and look at the insights, right? Just to tell you one nice, we have a data set about operations, right? How long an operation take, and then our doctors are doing the operation, and we ask. Generally, student says, "Yeah, this doctor is taking long time," and I ask them, "Shall we fire this doctor?" And usually, students' answer is, "Yeah, actually, he's taking a long time," and I'm like, "Why don't you think this guy might be the most experienced surgeon in the whole hospital?" And he is only doing the most difficult surgery possible. And that's why, because it's the most difficult surgery, he might be taking longer. And that's the insight you should be telling to the problem owner, not telling them that fight this guy. Okay. So that's what I mean by insights or knowledge extraction. And you cannot do it without domain knowledge. That's another interesting thing. So framework, there are multiple algorithms there. TensorFlow is there, PyTorch is there. because you are in Pakistan, so Alibaba is also available there. So if you want to start with PyTorch. It's easy, it's baby-like, so you can do a lot of things very easily and very fast. Then Keras is just a library to use with TensorFlow, and then you have different tools available on your desk. All of them are basically open access, so you can just, if you would like to learn it, you can do it immediately. Then we have generative AI because it is ruining the whole academics because students are so nice. Before I have to correct thesis 10 times and now students just generate their thesis, and that is an issue. Uh, but when I know that if the student has this capacity to write such a thing or not, and I usually tell them. So we have different things going on there, and one of them is agentic AI that you define a bit different bots, and then bots take over the work for you, and then they communicate with each other. Right. For example, instead of me having a secretary and Soil Sub having a secretary, we both have a bot who have access to our agenda, and they communicate with each other to make an appointment between two of us. Yeah. Then the trend four is the one where I'm following it, explainable AI and accessible data tools. And this is one thing, and ethical and responsible AI. That's another interesting thing going on. Quantum machine learning is interesting. I actually, this week, my PhD student is attending a school on quantum machine learning because I have no clue what it is about. So I sent him. And by the way, he's also a former COMSATS student. His name is Shoaib, I think. So he was in 2012 or 13. So he could be another of your speaker. Yeah. Uh, and then you have data scientist, data science specialist, data engineer, data steward, data curator, chief data information officer, and domain expert. All these are there. Yep. I still have few minutes, right? Yeah. These are different roles. Now, the question is, if you are studying mathematics, how can you go to the data science? I think so. That was the important question I promised to answer, or at least I can share my journey. To me, what is a data science? What mathematics you need? If you know what is a spaces, or if you know how the projections are computed, you are already in good shape. If you know calculus, and in calculus, especially if you know differential calculus, and don't go to very difficult differential calculus, okay? If you know how to apply chain rule properly, you are in a good shape to do data science. Yeah. And usually I tell to my student, what is a neural network for a mathematician? It is ax plus b, right? And then you should be able to take a derivative. And because you are doing the forward pass, because this computer scientist invented this interesting term forward pass. But what is a forward pass? Basically, you are creating a composite function. And when you create a composite function, we teach in the first year calculus course that to compute the derivative of such a thing, you just use chain rule. And for them, the misery is they don't know how to use apply chain rule. But as a mathematician, we do how to do it. So what is a neural network? You do ax plus b, and after ax plus b, you apply an activation function, which is basically a nonlinear function, and rest is just making composite function and keep going like this, and then you can go as deeper as you like. The only thing is when you are implementing it, you have to keep trace of how it is changing over the time and then be able to compute those derivatives using a chain rule. That's the neural network mathematics you require. Not more than that. Nothing more than that. When you are done doing this mathematics, you have to make prediction. For prediction, you need to be able to talk about intervals. Okay, the degree of certainty that your prediction is true or false. Then you need probability and statistics. Or if you want to do exploratory data analysis, you need to compute some basic distributions or things like those. So that's all the mathematics you do in data analysis, basically. Probably my world is too simple, so that's why I'm saying it. But I have not seen more mathematics than this in doing data science. Yeah. Also, at certain point, I made this slide for people who were from statistics department and they were like doubting if they can do data science. And to me, it is about estimate becomes learning, data point become example, classification becomes supervised learning, covariate become feature, response become label, and dummy variable become one hard coding. Right? So that's the extent of it. Then beside that, what you need to do, and I think so, I was kind of a little bit good when I studied BS mathematics, uh, was in programming. I learned Java programming from Abid Sab. He was one of the good teacher I got, and he spent quite a lot of time forcing us to learn programming. I learned Java at that time. And after that, I'm not afraid of learning any programming language because what is a programming language? It's a bunch of syntax. The problem was the logic or making algorithm or thinking algorithmically. That he taught me already in the bachelor. After that, what I need to learn, I can create an algorithm. I just learn the syntax and I'm done. And that is how I landed into my job as a computer science teacher when I came to University of Twente to apply for a job to become a computer science lecturer. They asked me a question that can you teach this course? I'm like, yeah, sure. They asked me like 8 courses. I say, yeah, I can teach all of them. And they say, how can you do that? I'm like, I have to learn everything from scratch. I have a PhD in mathematics, which is the most difficult topic in the world. At least people think so. Then why you think it is difficult to go read a book and teach this course? No, it is not difficult. You just need to give me some time to read the book. And this is how exactly I managed my job as a computer science lecturer. I taught all the courses which I never studied. And I will give you one example how everything is mathematics actually. This is just a joke that you just rename things to AI and everything is good. But it is becoming old now. You have to say everything is large language model. For Python, it's very easy to learn language. It is short, slow, dynamic, easy, and plentiful. Uh, when I was in COMSATS, I learned MATLAB and Maple, and I was pretty good in it. And that helped me a lot in a lot of my after career in my bachelor, in my master, in my PhD, and then my job. It helped me enormously when I was working with Philips, especially because their ecosystem was totally in MATLAB and I was good in it, so I can program good for them. But it is proprietary, so not many companies use it. So if you want to invest time learning something, invest time on learning Python or Java. If you learn Java, you can learn any programming language. After Python introduce a lot of laziness, I would say, because but Java don't let you do it. If you want to go really hardcore, go C. So Python many libraries for collection. You could use NumPy, Pandas, then Matplotlib for the plotting. Again, Pandas, scikit-learn or stats model. This is one thing I use a lot. Stats model especially. And for reporting, use Jupyter Notebook. And if you want to learn about these things, there are endless amount of material available online. I think so. I have said it already. There are two things which I mentioned to mathematician. One is SVG, singular value decomposition. And the machine learning people like to call it dimensionality reduction. And I'm like, what is the difference between the two, SVD and because I taught at certain point numerical linear algebra also. So half of the algorithms are actually a combination of these algorithms. Recently, we have submitted a conference to Triple AI, which is a gigantic conference. You can imagine the scale that this year 29,000 papers are submitted there. And my only contribution there was that I can recognize the use of singular value decomposition there, and I can compute the derivative just by looking at it. I can tell them, hey, this is where you are doing wrong, and this is why your function is not fitting, because I knew SVD. And the other thing is fast Fourier transformation or different transformation. You learn a lot of machine learning algorithm work with them, especially with the filtering part. All these are there. So the mathematics is pretty simple there, basically, not much. Additionally, you need to learn SQL. What is SQL? SQL is not more than set intersection and union and things like those. If you know how to use the set builder notation, you are done basically with SQL. This was the first course, by the way, I taught when I came to University of Toronto. And before that, I have never used SQL, never worked with it. And they gave me 3 months to prepare for the course. I saw it, and then I was going the corridor. I was talking to a colleague, and he says, "Yeah, you studied mathematics." I was like, "Yes." He said, "Okay, I will send you a book," and this book was all about set theory. And after that, I had never a problem with the SQL, right? Because he did his PhD in databases, so he did the formalism about SQL. So are so much intrigued or influenced by the syntax that we forget that what is happening there. If you ask in the set theory term, select something from these two sets where the union is this. That's what the whole question we are asking. And if you know how to do intersection and union, you are done, basically. And that's all SQL you need to learn, actually. So where to learn data science? There are many courses. I just randomly put few of them there. There is one guy I like the most is Andrew Nguyen. If you follow his courses, they are the best. At least I learned a lot from there. And even now, if I'm stuck on something and I don't get it, I go watch his videos. Few more books about that. Learning machine learning or data science. If you want to read it, a novel, it is Weapons of Math Destruction. Interesting book, but if you read it, it's a bit far. It takes you a bit for complete mathematical treatment, elements of statistical learning, deep learning by Ian Goodfellow. This is the fundamental book. Any mathematician should be able to read it like a bed book. And then the question about explainable AI, we see deep learning model as in black boxes, and we would like to open these black boxes. Just to give you one example of, you see that they want to recognize the wolf and husky, and theoretically, the machine learning should make a decision based on looking at the feature of the thing. But what it actually does is sometimes it do a lazy learning, because every time it saws that wolf is in the snow, so it start making decision looking at the snow, not on the dog. And that is what we like to discover in explainable AI. And there are plenty of algorithms. The field is getting mature. From 2020, it got the name, and then we conducted a survey paper, which is a survey of survey paper review paper in 2022, and at that time there were 1,000 review papers written about explainable AI. I'm not talking about fundamental papers. So every year there are like thousands of papers coming about explainable AI. Some books about explainable AI, interpretable machine learning by Christoph Molnar. It is freely available online, so you can just, if you know a little bit data science or machine learning, you can read this book. It's pretty much accessible. First 3 or 4 chapters are very easy to read, basically. He did a very good job, this person. I teach my master course and bachelor course using these books. Then my hobby, time series, collection of data. And if you want to do explainability with time series, it's another challenge, because for images, if we somehow magically discovered where the algorithm was looking and it was air, and we say, oh yeah, sure, the cats can be recognized by the air low. This is one of the biometric. But what we can detect from the time series, we cannot. And that's a fundamental issue we are trying to tackle now and develop new algorithm about it. So in explainable AI, I'm trying to see how can we explain sequence model for time series, and we have developed a new algorithm for concept-based time series. It's PhD student working disease progression, not prediction. It's different from prediction. But progression is like diabetics, right? When diabetic patient health, depending on the person, sometimes get better, sometimes get worse, right? And if we can be able to see the progression in future, this is one of the difficult problem. And can we do it data driven modeling and make it explainable? So that's we have one paper on this topic, and there is another one coming. Fraud detection in the banking sector, and in this area, yeah, it's difficult to get data, but we still able to do something about it. There is another data structure. This is from computer vision. It is used in robotics. It's called point clouds. And this is actually the topic of PhD student Schwab. He was, and also exploring the quantum X-ray. That's what I prepared for you guys. And in the end, I would say being a mathematician gives you an edge that you are not afraid of equations and numbers. Use this edge to its extreme potential. And if you sit down once in a while, leave your mobile out. TikTok and YouTube are very difficult to leave, and start reading it, a fundamental paper, a fundamental book. I think so you can access any engineering knowledge. That's my belief, and that's how I'm surviving in my job, and that's how I scored my job. Yes, thank you.
Thank you so much, Dr. Faizan Ahmed, for that incredibly insightful and inspiring presentation. We will we will now open the floor for the question answer session. If anyone have a question, please use raise hand features or type it into a chat.
जी मेरा ख्याल बच्चे सोच रहे हैं क्वेश्चन के बारे में। जी फैज़ान, वंडरफुल टॉक। So so there are two kinds of students here. Can you hear me?
जी।
Okay. So there are two kinds of students here. So one doing BS mathematics for data science, and the other ones are doing mathematics, BS mathematics. So what do you suggest to both of them? So if they want to pursue in this direction.
For doing BS mathematics, pure BS mathematics, this is what I did myself, right? Even after that, I did a master and a PhD in this topic in mathematics, and then I moved to data science. They can do an early switch also, because there are many universities now opening programs for a mathematician. Even in my own university, the master program I did, applied mathematics, now it has a specialization which is called mathematics of data science. So they go into the fundamental principles behind data science, and it is there. So it is open for both kind of student, studying only mathematics or studying it was automatically muted, sorry. So pay attention to learn some programming language, whether it is Python, but programming language learn.
I think
I
you
was saying that learning programming language does not mean that you learn how to use GPT to write your code for you, or copy paste code or combine code. No, challenge yourself to come up with new algorithm yourself, right? Just to give you a simple exercise, that sit down somewhere, think about, you have A is equal to 5, B is equal to 6. Now you want A is equal to 6 and B is equal to 5. How many variable do you need to be able to do it? This is a very simple exercise, right? Don't Google it. Challenge your brain to learn it. If you learn these fundamental and basics yourself, challenge your brain, the rest is easy. If you just go search in Google, everyone has thought about it. I learned this algorithm when I was studying myself in FSC even. I'm not talking about even university, right? Every solution is there. And the fundamental issue with programming is when someone else has written it, it's pretty much trivial. So focus on programming a bit more.
Okay, so what about the importance of mathematics in data science? How it can help you?
What is the importance? That is a very interesting question. We are not afraid of seeing the big numbers. We are not afraid of seeing tedious equations, right? If you have to write a basic neural network, you have to be able to understand forward pass and backward pass. And like I said, that what it is nothing more than, when you think it from a mathematician point of view, it is nothing more than computing um, applying a chain rule and computing derivatives. What I have seen, because I supervise very heavily bachelor and master student, and what I have seen where the student lacks, especially the student doing computer science, they cannot understand the computation itself. They cannot recognize the trends, right? Increasing or decreasing trend, for us, it is trivial. What is increasing, what is decreasing? You just look at the graph, it is going up, it is increasing. And sometimes for computer science student, we have to explain these fundamentals. And our eyes are trained for this, right? Like I'm telling you, this paper which we sent to AAAI, this was just a casual conversation with a colleague who was supervising a master student, and he was explaining, yeah, this is not converging. And I was like, okay, let's look at it together. I was like, yeah, why you are applying numerical scheme? It has an analytical solution. He was like, no, I just stand up, compute the derivative, put it equal to 0, compute it in 5 minutes. Because as a mathematician, my eyes were trained to do these calculations myself, and theirs are not. And this is your asset. Yeah. So
Okay, so this is
new,
about grasping the new ideas. A mathematics student can grasp new ideas in a much better way.
yeah,
So,
yeah.
what about research? So, in research, how mathematics helps in research in AI? How mathematics is helpful?
Yes, it is pretty much helpful. For example, I'm doing time series things now, right? Uh, we developed a new algorithm for concept shape. For concept shape, we have to work with the decompose. We needed to decompose the time series, right? What are the algorithm available to decompose a time series? Eigenvalue decomposition is the first thing we teach, we learn, right? We just started from there. My computer science student are not capable of applying them, but mathematics students are. This is the fundamental, right? If you know mathematics, differential calculus, and if you know programming, deep learning, you can learn very fast. And then beyond that, what is there in the research? People are stuck with what is the new things coming usually in new architecture. They develop new loss function, for example. How can they develop new loss function? Because they use some previously developed mathematics. You, what are you doing in the loss function? You are trying to compute the distance between these things. What kind of distances are available? We learn it somewhere in sometime in functional analysis, sometime in analysis, sometime in abstract algebra, different things like this. And that is our core knowledge, which is we have it in mind if you look at it. For example, another example is Adam optimizer. What is an Adam optimizer? Uh, what they do is that uh, we teach in calculus that you have to look, you compute the derivative, put it equal to zeros, then look, point left or right, if it, to compare to see if it is increasing or decreasing. But they have a parameter alpha which they need to optimize. So what they develop is a technique, right? Direction, they computed a directional derivative around it, right? And that is the trivial thing, and it is one of the most famous algorithm, and this item optimizer, which is used for deep learning. And still people are trying to develop new and new algorithm. This is one fundamental problem. The other thing, if you're going from mathematics side, for multiplying two matrices, you need three loops. Everyone knows that. So the complexity of this problem is O of n3. Do you know what is the fastest algorithm available there in the market? Its complexity is 2 power. Its complexity is not n cube, if n is the dimension of your matrix. It is n power 2.69. It's only a small difference of 0.31 actually. But remember, when you are doing a neural network, you are multiplying matrices of size million by million of time. So every smaller fraction. And it is still an active research to compute to even find a faster algorithm. And that is only coming from mathematician, not computer scientist, unfortunately. It's only going to come from some numerical algebra enthusiast. So if you want to go into really fundamentals research in data science, go study numerical linear algebra. What are the algorithms available there, right? Those are fundamentals. This is one type of research. The other type of research in data science is about applying these algorithms to different domains, right? That roughly everyone can do. Then being a mathematician will not give you a very big edge there, right? The computer scientist can do this job because you need a little bit of domain knowledge and probably you can recognize graphs better. That's the only edge.
Okay, thank you. Interesting examples. So what about stability analysis? So when you do stability analysis, then you need to know the proofs and stuff like that. So that comes, here comes the theorems and the proofs part. So do you think that's going to be helpful?
This is what exactly I did for my whole PhD, stability analysis. What is a neural network? Neural network is a dynamical system, right? And the issue is that in the dynamical system, if you have heard about chaos and dynamics and stability analysis of it, then if you want to converge to a solution, you have to show or prove that if it is stable or not, right? You have to prove all those nice properties, different stability properties. And this is exactly what my colleagues in mathematics department are teaching actually in mathematics of data science specialization. So these things are there. And by the way, if you take a look in the papers which are published in the Machine Learning Research Journal, MLR journal, Machine Learning Research, it is one of the most prestigious journal about machine learning. You will see that take any random paper. It's not about data crunching. No, it's only about proving theorems about different aspect of machine learning. Yeah. Another example. One of the fundamental thing which is coming very commonly used now in the industry is the Facebook profit, right? Profit like a profit, number profit. This is the name of the algorithm Facebook developed. If you see its fundamental paper, basically what is a Facebook profit is based on, it is based on a decomposition of a time series into a linear and non-linear term, like we divide it into seasonality and trend. They have defined a new kind of decomposition. And this decomposition cannot be proven without knowing all the theory or analysis. So their fundamental paper, one thing is their package, which everyone use blindly. And the other thing is to be able to interpret those results or to be able to understand what is happening there, you need to learn the paper. And in the paper, there is nothing else than theorems. It's all about proving its stability. It's all about showing that, okay, that we have decomposed it, but is it the exact decomposition or it is an approximation of the original or is there an error? If there is an error, can we contain it? What is the bound of this error? All these things are there, right? And you need this analysis. If without analysis, there is no fundamental contribution in the data science area. right? And who is doing it? It's mathematician who is doing it, not a computer scientist. They are afraid of doing such things. I'm located within computer science in a group which is formal method, and these are basically computer scientists in the disguise. They are mathematicians basically. They do the mathematics, which is which is beyond mathematicians even basically. They talk about Galois theory. They talk about um, different aspects of geometry, right? They talks about curves, they talk about tangents, because they have to show uh, that they have to basically prove that the program they have developed is actually doing the things we have promised it to do. They are doing a formalism there. So all half of my colleagues doing a PhD in computer science, but they are basically mathematician. We recently had a student who did his master in algebraic geometry and he is doing a thesis on a cybersecurity, by the way. So risk
Okay,
analysis.
that's very nice. Okay, I have a very different question now. You studied from one of the prestigious institutes of the world. So what if, these undergrads wants to follow your journey, your, footsteps. So they want to study from the prestigious institutes of the world. So what do you suggest? What are the opportunities available? Because you are in the Europe and you have the eye on all these opportunities. So can you suggest them, or can you
Uh,
tell them how to plan for applying there?
my answer might be a little bit controversial, Sulsan. If I look, but this is my personal opinion to a certain extent. I would say if you want to go out for studying, go out for applied studies, right? Application. You can go do mechanical engineering masters. You can go and do. Then I will come back to where these opportunity, where you can do it. You can do in industrial engineering, operations research, computer science even, right? For a simple reason, this is my struggle when I came here to study mathematics. The way we approach mathematics, or we used to approach, I don't know if it might have changed in Pakistan. We do engineering mathematics basically. Here, their engineers do much more mathematics than we do there. And because we do engineering like mathematics, so it is difficult to work with the mathematicians here. They do mathematics like a mathematician. So here, I have never heard someone saying that I'm proving theorem, so that's why I'm doing pure mathematics. No, proving theorem is the fundamental toolbox of any mathematician, right? Uh, so where should you go? Germany, but like I said, that their level of mathematics is quite high, right? And Germany, you have a lot of opportunities. If you are a bachelor student, you can look for a different master program. And being with a mathematics degree, you are admissible to many master program actually, not only in mathematics but also in mechanical engineering. In some cases, electrical engineering. What is electrical engineering? It's in mathematics on imaginary numbers and signal and a Fourier series basically. You can apply for master degrees in computer science in certain universities. Like I said, that informal methods is basically mathematicians at work. And of course, you can apply for your own mathematics field. Uh, Industrial engineering is another interesting place. And this is nothing more than doing mathematics, basically. You are doing operations research. If you have studied operations research, industrial engineering is another master program, which is pretty common in many European universities. And it is 100% mathematician. So it's mathematician who know a little bit of programming. And they are also moving towards AI in data science. Of course, AI master, any master, they accept a mathematician. They expect you to know a little bit programming, but they expect mathematician. They accept the mathematics student. So this is for the bachelor student. For masters, it will depend on your thesis. It will depend on your letter, and which bring me to, when I say letter, I will come back to this one more time. And it will depend on the topic. And because in most cases, the PhD positions are project based. So if it connects, it connects. If it doesn't connect, it doesn't connect. This is one part. The second part is because I'm talking to a new generation which grew up with WhatsApp and TikTok, and then you are so much used to of it. Sometimes I receive email which are written in a TikTok style or WhatsApp style. Maybe I'm still bit okay, not really young, but I'm not that old. I'm in 40s. But my colleagues are not in 40s. They are in their 50s or 60s who have decision maker, and they don't like this style of TikTok writing or WhatsApp writing in the emails, or they really feel bad. And it is probably it is my wrong experience. Okay, I have to be careful when what I'm going to tell you. Sometimes I receive email without any salutation, and if I can close my eyes and guess from where it is coming, it's either coming from India or Pakistan, right? And without any salutation, they just start something from random, right? This is one, or completely GPT written emails, very long. So avoid these things, please, when you approach someone. And don't approach people randomly, and don't write emails to all the professor in that department, because we are human and we talk to each other. And the last thing is, last year we had an interesting motivation letter against a PhD positions, which was announced. It was a colleague who was doing the screening, and he showed me this one. And what this guy did is that, oh, I am so much eager to study in University of Twente, and he basically literally copy pasted the full paragraph from Wikipedia page about University of Twente. And this person even did not bother to remove the hyperlinks, right? This is a killing mistake. It looked trivial that people who make such a mistake, but they do. And after GPT, another issue is now we get overly long string. No, we are not interested in it. We just want you to tell us exactly what you did as precisely as possible. Because usually, I'm talking about now PhD positions, right? How much time a professor has to review your application? Probably 5 minutes, right? If you use a lot of nice adjective about you, who cares? Huh? Just tell me precisely, hey, I know this and this thing. I have studied this and this courses, and that's why I find it interesting that this topic is relevant, and I can do research in it. That's the message. If you write that, hey, I have studied in the prestigious message, which is the best university in the world, and because of that, and your university is the best, I know how my university is. Yeah? So that's so the time is the essence here, that you need to concise, don't leave the information. So yes, there are a lot of opportunities for mathematics graduate. I have seen student switching from mathematics to computer science many times, to mechanical engineering, electrical engineering masters, AI masters, which are accessible. In Germany, there are many universities offering it because it has still no fee. In Netherlands, I'm also a program director, which practically means I'm in charge of a program, business information technology. But the problem with the Netherlands is there is a high fee for the master program. We still charge fees, so it is pretty expensive country also to live in. So these are few tips which goes beyond what are the opportunities, but this is what I regularly see happening because I'm sometimes part of hiring committees also.
Thank you, Faizan, for a detailed answer. So, if any of these students have any questions, so can they contact you?
Yes, I put my email address in the there. Of course, they can contact me about. I'm pretty open in telling student, but sometimes I have to explain it. I'm living in Netherlands, and we here people are straightforward to the extent of being rude. Yeah. So we don't use the British style of buttering up everything. So we just hear people just say straightforwardly. Because I'm living here for a very long time, sometimes probably my answer will be very sharp and one-liner. Which doesn't mean that I don't want to talk or I don't want to help you. It just means that, okay, I have only half a minute to answer. But you will get answer from me whenever you contact me. That's for sure.
Okay, thank you. Thank you, Faizan. Ji Bachu, any other question?
There was a question, hand raised a few minutes ago from two students at least.
I think Adam Issa has have a question. He has raised hand. Adam, if you have any question, unmute your mics and ask now.
By the way, if someone is looking for thesis topic for their, especially the student who are doing the data science and mathematics combination, yeah, maybe I can suggest you something. Yeah, if someone is interested, let me know. Yeah, I might not be able to supervise you actively, but I can have a conversation to give a direction about it, that what they can do.
That's a very generous offer. Thank you, Faizan.
Yeah. Still, I have many friends in working in the mathematics department. Actually, I was bragging last week to my colleague that even if I go today to mathematics department office, from PN till chairman, I am pretty sure all of them will recognize me. So I don't know how much it is true. Probably next year when I visit Pakistan, I will try it.
You are most welcome to come. Rather, just let us know when you are planning to come to Pakistan, and we will have your, physical seminar, because we would like to hear all of these things again and again.
Yeah, sure. I will visit. It's good. It's been like 10 years I have visited COMSATS.
Okay, that will be nice. Saad, over to you.
Okay. On the behalf of the Department of Mathematics and SIAM student chapter, I would like to extend our deepest gratitude to Dr. Faizan Ahmed for sharing his invaluable journey and knowledge with us tonight. And also our special thanks to you and our esteemed faculty member for their presence and continuous support. And finally, thank you to all our attendees. Your participation is greatly appreciated. And once again, thank you to Mrs. Shan Ahmed for Tlawat. Okay, this concludes today's seminars. The meeting will be end now. Good night and take care.
Thank you very much, everyone.
Thank you, Faizan.
Bye.
Thank you all. Thank you, student.
Thank
Thank
you,
you.
sir. Allah Hafiz. Allah Hafiz.